Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 6 to 10 of the Algebra 2 Trigonometry Regents exam for June 2015. All right, let's take a look at number 6. It says, which expression is equivalent to x to the negative 1 y squared over x squared over y times y to the negative fourth. Okay, so you want to remember that any term with a negative exponent may be reciprocated. So this term has a negative exponent, this term also. So this term could be reciprocated to the denominator, and this term could be reciprocated to the numerator. So let's keep that in mind. Okay, that's known as the reciprocal property of exponents. If we apply that here, we're going to have y squared. If we reciprocate y to the negative 4, we'll have y to the fourth. Note that the sign of the power changes upon reciprocation, okay? And we have x squared. If we reciprocate x to the negative 1, we'll have x to the first power. Next, we're going to use the product property of exponents. Anytime you multiply exponents with the same base, you add the powers. So we're going to have y to the 2 plus 4 over x to the 2 plus 1. Okay? If we simplify this, we have y to the 6th over x to the 3rd power. Our answer is option number 4. All right. Let's take a look at problem 7. It says, what is the solution of the inequality 9 minus x squared is less than 0? So solving inequalities is very much like solving an equation. Remember that anytime you divide by negative, you switch the sign. And also when you have an absolute value with a less than situation is bounded, and if it's greater than, we have to break it up like option 2. Okay? All right, so let's go ahead and solve this. We have 9 minus x squared is less than 0. So solving just like an equation, we'll subtract 9 from both sides. That yields negative x squared is less than negative 9. And then we divide both sides by negative 1, or you can multiply by negative 1, it's the same thing. So we're going to have x squared. Now, please do not forget to switch the order of the inequality whenever you multiply or divide by negative 1. So we have x squared is greater than 9. Now, what we're going to do is we're going to take the square root of both sides. Anytime you take the square root of a square, you have to introduce the absolute value, okay? Absolute value of x is greater than the square root of 9, which is 3. This is because if you square plus or minus 3, you get the same result of 9, okay? Now, notice we have an absolute value quantity and a greater than, so this inequality has to be solved by splitting up. If it were less than, then we can solve it, and we have a sandwich situation like option number 1. So we're going to have plus or minus x is the same thing as the absolute value is greater than 3. So we're going to split it up here. We're going to have negative x is greater than 3 or positive x is greater than 3. The right inequality is already in a solved state. To solve the inequality to the left, you simply divide both sides by negative 1. Okay, let's go ahead and do that. So divide by negative 1, divide by negative 1, and then that yields x is less than 3 or x is greater than 3. Answer is option number 2. All right, let's take a look at number 8. It says, what is the area of the parallelogram that has sides measuring 8 centimeters and 12 centimeters and includes an angle of 120? Now, one thing you want to remember, just a side note, is that sine of 60 degrees is equal to root 3, root 3 over 2. Okay? Now, this is also equal to another angle where sine is positive and the reference angle is 60 degrees. Let me show that to you real quick. So we know that sine is positive in quadrant 1 and also in quadrant 2. Okay? Remember, all students take calculus. So in quadrant 1, if this is 60 degrees, there's also 60 degrees. Sine of 60 is root 3 over 2. okay, because sine is positive here. Sine is also positive here. So the angular measure that has a reference angle of 60 degrees will have exactly the same result as root 3 over 2. So what is that? Well, we know that a complete angle on a straight line is 180. If we back up 60 degrees, that takes us 120, just subtracting 60 from 180. So guess what? This shows us that sine of 120 is also root 3 over 2. Okay, the other ones with 60 degrees as reference angles, um, namely 240 and 300, are going to be negative root 3 over 2. So keep that in mind, okay? If you have an advanced calculator, you can figure this out, but I'm just showing you why this is the case, okay? All right, so let's find the area of a parallelogram. So remember that the area of a parallelogram is 1/2. Oh, it's not 1/2. That's area of a triangle. Area of a parallelogram is AB sine C. Now, when can you apply this fact? You can apply this fact when you're given two sides and an included angle. Note, the angle must be included, okay, as indicated here, included. So if you have two sides, AB, and an angle C, let's make this sufficiently large so you can see it. The area of the parallelogram is going to be 1/2 AB sine C, all right? You might remember the formula 1/2 AB sine C. This is the area of a triangle, okay? This is the area of a triangle. So in this case, you notice that the trapezoid is made up of two triangles, right? So the area of one of this is 1/2 AB sine C. This is 1/2 AB sine C. So what happens when you combine both of them together? So combined together is going to be AB sine C for the area of the whole parallelogram. Okay, so that 1/2 is a common mistake that most students make. Okay, I haven't made that mistake just now, but be careful. There is no 1/2 for the area of a parallelogram. In this case, the sides that are given are 8 and 12, and the included angle is 120 degrees. Note, it must be between the two sides, okay? So the area of our parallelogram is going to be A, which is 8, times B, which is 12, sine C, 120, okay? 8 times 12 is 96. Now what is sine 120? Remember we talked about it here. Sine 120 is the same as sine 60, which is root 3 over 2, or 0.8660. Okay, so we're going to put the value here, root 3 over 2, and then just simplify, okay? 2 goes here 1, 2 goes here 48 times, and then multiply across. You have 48 rad 3 as the area of your trapezoid. So our answer is option number 2. All right, let's take a look at number 9. So for number 9, we are to find the expression that's equivalent to 5 over 4 minus rad 11. So this is a rationalization problem where we have to rationalize the denominator. So we have 5 over 4 minus rad 11. So what we're going to do to rationalize the denominator, remember you may not have a radical as a square root, as you multiply by the conjugate. Okay, what is the conjugate? The term you get by inverting the sign in between the integer and the radical. So 4 plus rad 11. The same thing on the top and the bottom in order not to change the problem. So we just simply multiply the numerator across. We're going to have 5 times 4 plus rad 11. And then what do we have downstairs? Now that's the complicated part. Downstairs we have the difference of squares. Okay, if you know your difference of squares formula, you can simply determine that this is 16 minus 11. But let me show you the steps so you can really see what's happening here. 4 times 4 is 16. That's first. And then plus 4 rad 11. That's outer. Okay. And then inner is going to be negative 4 rad 11, and then last is going to be minus times plus minus root 11 square. Okay, so if you simplify further, we have 5 times 4 plus root 11 divided by, you notice I didn't expand distribute the top. I'm hoping that 5 might be a factor of the result at the bottom. So we have 16. Now notice what happens since these two are opposites, they cancel out. And then minus root 11 square, square and square roots are inverses, so they cancel each other out, and you have 11. Okay, so this becomes 5 times 4 plus rad 11 over 16 minus 11 is 5. How convenient. The 5's divide out, and your final answer is 4 plus rad 11. Okay, answer is option number 1. All right, let's take a look at number 10. It says, given y varies inversely as x, when y is multiplied by 1/2, sorry, then x is multiplied by. So anytime you have an inverse variation, you have, let's see, y varies inversely with x. So this is how you write it. Or you can write it as y equals k over x for some constant k. K is known as a constant of variation. So if you multiply both sides by x, sorry, you have y times x is always a constant. All right, so when you multiply both of them together, you always get the same thing. So there's a change that has been made here. So what I'm going to do is I'm going to write this as y. The first y times the first x is equal to the second y times the second x. So y1 x1 is equal to y2 x2 because of that constant of proportionality. Okay. All right. So now what happens is that I multiplied y by 1/2 to get my y2. Okay. So I'm going to have y1 x1 equals 1/2 times y1. That's how I got y2. So by multiplying y y1 by 1/2 to get y2, what's going to happen to x2? What's going to be my new x2? Okay. All right, so let's simply solve this for x2, and then we're going to see what we're going to be multiplying x1 by. Okay, so hint, think about this. What is the inverse of multiplying by 1/2? The inverse of multiplying by 1/2 is dividing by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. Okay, so it just basically reciprocates the operation. So our answer should be 2. But let me show you the steps so you can really understand what's going on here. I want to find what x2 is as a result of multiplying y1 by 1/2. Okay, so to isolate x2, I'll multiply by 2 over 1 to cancel out this 1/2. And then, well, let's do that first so no one gets confused. That cancels out. So we have 2y1 x1 equals y1 x2. And then divide both sides by what to get x2 by itself? Divide both sides by y1. y1, that divides out. And that divides out also. This is x1. Our answer is x2. The new x2 is going to be 2x1. So what is this telling us? If you multiply y1 by 1/2 to maintain that inverse variation, you have to multiply x1 by 2. Okay, so our answer is option number 2. Thanks so much for taking the time to watch this presentation. Do not forget to subscribe to our channel for updates to the remainder of this review series. And if you found this beneficial, do give us a thumbs up. We appreciate it. And if you have any questions, just include it in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.